Today I wanted to start chapter 7. Chapter 7 is all about exponents. So with exponents, what we end up having is a whole lot of rules of ways to deal with different things we see. Today we're going to talk about how to deal with, or how to evaluate expressions with exponents of zeros and negative exponents. Okay, so that's really the goal here is when we see an exponent with a zero or an exponent with a negative, how do we handle that? So the easiest way I can explain that is we all know what like 2 to the third power means. 2 to the third power is just 2 times 2 times 2, right? Or 8. And then we know what 2 to the fourth power is. Well, that's just 2 times 2 times 2 times 2, or 16. And if we keep that pattern going, 2 squared is 2 times 2. 2 to the first is equal to 2. And basically, as we're going down this list, the question becomes, how do we go from a 16 to an 8 to a 4 to a 2? Going down, we can think we're dividing by 2 over and over and over again, right? Going up, you can think you're multiplying by 2. Well, if we keep that pattern going and we say we're going to divide by 2 again, well, 2 divided by 2 is going to end up being 1. So that means as we keep going down here, basically, if you have 2 to the 0 power, that's going to equal 1. And that's actually true for all numbers. Our general rule is simply going to be anything that has an exponent of 0 to, or any number raised to the 0 power other than 0, the answer is 1. So 2 to the 0 power is 1. A million to the 0 power will still be 1. Because basically what you always end up with is that number divided by itself. Okay, so really what 2 to the 0 power kind of means, you can think of it as, is 2 divided by 2. And we know that any number divided by itself will always be 1. Okay? So basically we have a rule that says any non-zero number raised to the 0 power, right today, is 1. Okay? Now, I'll talk about 0 in a second. But to keep going, to deal with this, a negative exponent, okay? Now, if we keep this pattern going again, so now we can, go into negative exponents, like 2 to the negative 1 power. Well, if we keep that going again, and we just say this is 1 divided by 2, okay? So what ends up happening here is all that happens is we end up having a positive number denominator. What I want you to understand is negative exponents do not mean negative numbers. What they actually typically mean are small numbers. If we keep that going, 2 to the negative second power, if we divide a half by 2, we get 1/4, which really came from 1 over 2 squared. This 1/2 came from 1 over 2 to the 1. So basically what ends up happening is this 4 to the negative third power, if you see a negative exponent, all that means is those, we have 3 4s, those end up just going to the denominator, and then that makes that negative 3 turns into a positive 3. So the answer is actually 1 over 4 times 4 times 4, or 1 over 64. Okay, so it just basically becomes a very small number. All right. Now, when we deal with 0, 0 is kind of a special number. Any number like 0 to the 0, that is going to be undefined. 0 to the negative third power is also going to be undefined, because basically what you end up having in all of these cases is when you use the rule and you make that in the denominator and make it positive, well, now you're dividing by 0, and even in this case, you're not allowed to divide by 0, so that's why it becomes undefined. Okay, so just know that these rules only work for non-zero numbers. Okay, so basically we're going to have two rules. One rule is going to be any number raised to the 0 power is going to be 1. The other rule is if you see a negative exponent. Okay, if you see a negative exponent, basically all you have to do is move it to the denominator and make it positive. Okay, so let's try a few examples. If you see 3y to the negative second power, well, remember that negative second power is only attached to the y. So that 3, nothing is going to happen to it. So that 3 stays exactly where it is. And because, you can think of 3 as 3 over 1, that would stay in the numerator. But those y's are simply going to get moved to the denominator. And when you move it, you make it positive and you're done. Let's try this one. So a common mistake here is people will think a negative and a negative here, those negatives will cancel. That's not actually true here. Because this negative, the negative in the exponent, that means what we're going to do is we're going to take that negative 2 and make it to the positive fourth power, but we're going to move that into the denominator. Okay, so we're going to flip it. Now, when we do that, in this particular case, this is going to end up being positive, because remember, when we have parentheses like this, that means that is the same thing as negative 2 times negative 2 times negative 2 times negative 2. So we have 4 negatives. Well, if we have an even number of negatives, that will end up being a positive. And 2 times 2 is 4, times 2 is 8, times 2 is 16. So this does end up being a positive, but it's not because these cancel. They do not, okay? If this was a 3, okay, so it was an odd number, we would have an odd number of negatives. The final answer would have been negative, okay? What I mean is, just to make another example, if I had negative 2 to the negative third power, that would be the same thing as 1 over negative 2 to the positive third, which is the same thing as 1 over negative 2 times negative 2 times negative 2. Now, because I have 3 negatives, the final answer is negative 2 times 2 times 2 is 8. So it would be negative 1/8. Okay? Let's try another one. And basically, again, you can think, if you see a negative exponent, all you have to do is flip it. If it's in the numerator, move it to the denominator. If it happens to be in the denominator, we'll move it to the numerator. So in this case, the easiest way I can say to do these is one letter at a time. So this is x to the negative third power. So that means those x's need to get flipped. So instead of them being the numerator, they go to the denominator. So I have x to the positive third power now in the denominator. This a to the 0 power. Well, anything to the 0 power is equal to 1. So basically, it's gone. It becomes, we're timesing by 1. So it just goes away. These y to the 5th, well, because they're positive, they can just stay exactly where they are. Not sure why I started that so far over. And they stay in the denominator. They were in the denominator before, and they are positive, so they stay right where they're at. because we're basically left with nothing, we got to put something up here so it ends up always being a 1 because you'll have a 1 over a 1. So that would be your final answer for that one. Now, remember a couple chapters ago when we talked about exponents, this is much different than the problem we did before up here with the parentheses, okay? Because this -2 is not attached to that negative, okay? So that negative is just going to stay out in front all by itself. Now, the 9 is going to get raised to the -2 power. So that 9 has to go to the denominator, and then we make it positive. Okay, and then 9 times 9 is 81. So my final answer is -1 over 81. Okay, let's try another one. If I had 4 over a to the -3rd, well, the 4 stays exactly where it's at because it's not raised to a negative exponent. These a's, because they are raised to a -3rd power, they also have to go to the top, so that becomes a to the 3rd. If you want, you can put it over 1, but you don't actually have to put that part of it if you don't want to. Okay, so the final answer would just be a, or 4a to the positive 3rd power. All right, let's try a couple more. 2/3, a to the -3rd, b to the 4th. Well, the 2 and the 3, neither one are raised to an exponent, so you just leave them exactly where they're at. You got a 2 over a 3. The a's are raised to a negative, so those a's have to get moved down. So the a's come down here, and they just become positive 3. The b's are raised to a positive number, so they stay exactly where they are at. Basically, if you see a negative, move it. If it's positive, leave it where it's at. Okay. And then you might run into some where you have to do some substitution before you evaluate. Okay, so we have evaluate b to the -2nd power if b is -3. The most important thing to here remember is you're putting that -3 in for b. So this is one that you would have to use parentheses because the b is becoming a -3. Okay, so now that's important because now both the 3 and the negative have to move together. So the negative exponent means we got to flip this. So those -3's go to the denominator and become positive. Okay, and then -3 times -3 would be a positive 9. So again, this is one that if you just look at the answer, it kind of looks like the negatives cancel. They do not. And this is not a negative times a negative. This is a negative raised to a negative power, okay? If this happened to be an odd number instead of a 2, my final answer would have ended up being negative, okay? Let's try one with 2 substitutions. So this one, I would just rewrite it as 2 times x to the 0 power times y to the -3rd power. But instead of x, I'm going to plug in a 7. Instead of a y, I'm going to plug in a -4. Okay, so we have basically that. We know that anything to the 0 power is a 1. And then this one, the -3 means I have to take the reciprocal of this. So this becomes my -4's go to the bottom. I have 4 of them down there, and I end up with a 1. So now if I just multiply that straight across, 2 times 1 times 1 is just a 2. 4 times 4 is 16. 16 times 4 is 64. Because it's an odd number, I have a negative times a negative times a negative. That would be a negative. So my final answer is going to end up being a negative. And then this fraction would reduce to -1 over 32. Okay, so there would be my final answer there. So try a few of these. Look at the book, see if you have any questions. If you do, let me know. But other than that, hope everything's going well. See you guys later.